Hello friends, welcome back. Welcome to the concepts of CISSP. We are discussing security architecture principles, right? And as you have noticed in this series, I am continuing this discussion of architectural principles and design principles in reference to ISO IEC 19249. So the architectural principle which I have covered so far in 19249 is we have covered the domain separation, we have covered layering, and then we have covered encapsulation. If you look into these architectural principles in totality, like from a single point of view, then you will realize that these concepts are not entirely independent. They kind of complement each other. One more important thing just to remind you, as when we are discussing architectural principle or design principle, is that the distinction between architectural and design principles. In architectural principles, we are concerned with finding a balance between the functionality and the security of a system, wherein in design principles, we are more focused in finding the potential risk and how we can mitigate the risk, and I mean all those risks which are related with the design of the system, right? When the system is implemented, then there will be new risk discovered as part of functioning of the system. But here in this domain, since we are discussing security and architecture engineering, our design principles will focus on those risks which are related with design. So let's come back to the architectural principles which we are discussing, and there are two architectural principles which are left, and these are virtualization and redundancy. First we will discuss redundancy, then we will discuss virtualization. So redundancy is designing a system with replicated components, right? So you have a system. In order to achieve the maximum availability of the system, you design that system with replicated component, so that system can continue to operate if there is an error or if there is an excessive load. So as you might have got the hint or got the idea, that redundancy is primarily focused with the availability of the system, right? So out of all those 6 fundamental information security principles we have discussed, the goal of redundancy is to provide maximum availability or to uphold the availability, right? So how we enforce or how we implement redundancy to a system, there are different ways of doing it, and it depends on what systems we are talking and what redundancy we are trying to apply. Can we have a 100% redundant solution? I think the answer is no. You can't have a 100% situation where a system is available at all the time. To my experience, I have seen some networking devices. When I started my career in TCP/IP networking, I saw some of the switches which have an uptime of 17 years, right? So my experience was like, the overall experience was 8 years, 8 or 9 years at that time, and the device which I was working on was having an uptime of 17 years. That was remarkable. There was this redundancy of the power system which was being fed to the system, right? So technically the system never rebooted or never lost power in last 17 years. Okay, so that is the power level redundancy which actually ensures the system uptime, right? So you might have understood what is redundancy. Redundancy is basically designing a system with replicated components so that system can continue to operate in spite of any error or any excessive load. I will give you a few examples. One example I already gave is the uptime of a system which was ensured with dual power supply, and the switch never went down for last 17 years. That was incredible. Now the common examples for networking folks is a spanning tree protocol, and you all know that what is a spanning tree protocol. So if you have got two switches and these switches are connected with a wire, there is a high chance that the wire can break or the wire can experience some problem, right? There is some error. There is some mouse who actually who bite the wire and the connection is broken. So what you do, you put redundant connection. So instead of one cable going from one switch to another switch, you put another cable, and you put another cable, or you may have 4 cable, 8 cable, depending on the level of redundancy you want to put. Now what happens when you put redundancy in a system, then to have an arrangement or to have an agreement for that redundancy to work, you must have a control plane logic or control plane protocol, which kinds of mediate between different redundant connection, right? That's where this spanning tree protocol come. This is just an example, right? So on a layer 2, if you have in TCP/IP, you have got 5 layers: physical layer and data link layer. So cable is basically physical and data link layer. So when you have redundant cable, you need a protocol which can avoid any traffic loop happening between redundant connection, right? So wherever you have redundancy, there is a chance of loop. It holds true everywhere. So if you have a link layer redundancy, there is a chance of having loop between two devices for that frames which are being propagated from one switch to another switch. In case of routing protocols, if you have redundancy for different routing paths, there may be loops for the routing paths as well. Then there you have techniques to avoid routing loops, and it is specific to a specific protocols. Like in OSPF, you have a different loop avoidance mechanism. In border gateway protocol, you have different loop avoidance mechanism. But nevertheless, you have some mechanism to avoid the loop. So to bring redundancy, you have replicated components, and to make that all replicated component work together in harmony, you require some control plane protocol which can mediate the traffic, or which can have some sort of protocol for optimal working of that redundancy, right? So the example of a spanning tree protocol was for the link layer redundancy. Then you have a specific loop avoidance mechanism for routing protocol as well. The other example could be between the database system, right? So you have got a database which is holding some critical information, right? And you want that database to be available all the time, and not be its availability has to be 100%. So you create another data set or data store, you can say in a more technical term. So you have got two data stores, primary and secondary. Now if there is any change which is happening on the primary data store, you want that change to be replicated to the secondary data store, right? So both the database system, database tables must be synchronized, right? So there has to be a control protocol, or there has to be a method, so that all these different primary, secondary or tertiary database are synchronized, right? So the from a security point of view, what we have to be mindful of, that there should be a quick method of error detection and error control. So in case of database system, when we are having redundant database, there has to be a check of error control, error detection and error control. You can think of a bank transaction, right? So in a bank transaction, someone sends money from bank A to bank B. So there are different instances where this information is maintained in some database. So to have the complete 100% successful transaction from bank A to bank B, the transaction should flag successful if the amount which is detected from bank A is properly replicated to bank B as the deposit amount, right? And if at any point of time in between this communication a system fails, then the whole transaction should fail. That is something which is called atomic transaction. So the atomic transaction principle says that if you have database transactions happening, and this database transaction is made up of 10 different steps, and at any point of time if any step fails, then the whole transaction should roll back or roll out, right? So this is another example. So first example I gave you from the world of TCP/IP networking, the example of avoiding routing loops, the example of avoiding switching loops with a spanning tree protocol, or different loop avoidance method in in OSPF or BGP and ERGRP. If you're a networking expert, you can go back and refresh your memory there. And the other example which I gave to you is database system, where you have the property of atomic transaction, which ensures that the redundant systems are 100% working perfectly fine, and there is no discrepancy between the redundant sets. Because if there is a discrepancy between the redundant sets, then the whole purpose of redundancy fails, right? So this is an important point we should be mindful of. The other example of redundancy, a very popular example, is RAID system, right? So you have got different RAID level: RAID 0, RAID 1, RAID 2, RAID 5. So what happens in RAID system, that you have redundant array of disk, and you have got different type of control plane logic, which determines that how much redundancy I have for certain storage device, right? We will discuss RAID systems later in the discussion, but at this stage, from principle point of view, you should know that the RAID systems refers to the principle of redundancy, and there you have a control plane logic which acts in harmony, or which acts in a way that that ensures the consistency of the database between the redundant arrays. So that's all about redundancy. Now let's talk briefly virtualization, right? There is nothing much to discuss in virtualization at this stage. Virtualization in real world is about to have optimum use of resources and to have the capability of a scale up and a scale down as business require, right? So this was the driver of virtualization. From security point of view, we should know that the term virtualization is used when we are emulating a real hardware or a simulated software, right? So what we do here in virtualization, that we have a piece of hardware and we emulate that hardware into different operating system. So if we are emulating a hardware into operating systems, it's called virtual machine. So basically, virtual machine is a type of virtualization where we are abstracting the underlying hardware, right? Now if we are virtualizing the operating system itself, it's called containers. So these are the two virtualization world we should be aware of at this stage. So from security point of view, we should understand that at all the layers, like on the hardware layer or the operating system layer or at the container layer, we should be applying the security policies in a way that addresses that layer, right? So on hardware layer, we will be having hardware kernels or bare metal software which manages that hardware, and we should be having independent security policies which talk of that hardware layer. Then we have operating system controls. It depends on what type of operating system or what type of virtual machines we are actually creating from that hardware. That will have its own set of security controls, and the containers will have the same set of like some different set of security controls, right? So we can't say that if an operating system is secured with some set of controls, then the container is also secured. Container will require some different kind of security controls. So virtualization can be used to achieve redundancy in a way that you can have virtual systems as replicated components for a hardware system, and that can be used depending on the business need. You can have a scaled up version, a scaled down version. If you have more traffic, you can have more hardware allocated to a virtual machine. So this works in a way that virtualization can complement in a very cost effective way to the idea of redundancy. That's all about this video. I hope this video was useful, and if you like this video, put a thumbs up. We will be moving to our next topic in security architecture and engineering. I hope to see you again in next video. Thanks for watching, and best of luck for your CISSP exams.